Let's talk about inverse trigonometric functions. As we know, functions that are one-to-one pass the horizontal line test, and therefore they've got an inverse function. However, the sine and cosine functions do not pass the horizontal line test when considering their graphs in their entirety, but it doesn't mean that there's no interval in which an inverse might exist. Let's bring over a graph of y equals sine of x. Okay, so this is y equals sine of x. And as we can see here, this does not pass the horizontal line test, because if I were to put a line here, say y equals 0.5, we would see there's multiple points in which this hits the graph. So there is no inverse function. However, if I look at only the interval from x equals negative pi over 2 to x equals positive pi over 2, just this portion in the middle, this is a very special portion, because if I were to put y equals 1/2 in here, it will only hit something in this interval once, and I can actually move this up and down, and we'll see that it passes the horizontal line test in its entirety. And in addition to that, it captures our entire range from -1 to +1. So when I'm talking about the inverse sine and inverse cosine function, I'm going to look at just one interval, so that way I can get all of the range possible and it passes my horizontal line test. Okay, so let's look at the definitions here. Y equals arcsine, same as sine inverse, of x if and only if sine of y equals x, arccosine of x if and only if cosine of y equals x, arctangent of x, and again these are sine inverse, cosine inverse, tangent inverse, if and only if tangent of y equals x. So I've got some restrictions in the domain. The domain of these is going to be from -1 to 1, for both sine and cosine. Arctangent can go from -infinity to +infinity. The range is going to be -pi/2 to +pi/2 for sine and tangent, arcsine and arctangent, whereas for cosine, this will be 0 to pi. So what does that mean for our unit circle? Well, you may recall our unit circle, and I've got one down here for us to look at. Let's start with arccosine, the one in the middle, 0 to pi. From 0 to pi, I would be looking at only the top half of this circle and not the bottom half, because that's going to be greater than pi. Okay, back to 2 pi. For arcsine and arctangent, I'm going to go from -pi/2 to +pi/2. So -pi/2 is the same as 3 pi/2. Just think of this as, instead of going counterclockwise to pi/2, we're going clockwise this way. This would be -pi/6. This would be -pi/4. This would be -pi/3. This would be -pi/2. An easy way to remember this is find, for example, +pi/3. That's up here. Well, now flip it over the x-axis, that'd be down here. 5 pi/3 is the same as -pi/3. Okay, so what does this mean? For arcsine, we're going to be looking at the right half of the circle. Okay, adjust for negatives as needed. For arccosine, we're going to be looking at the top half, and for arctangent, we'll be looking at the right half. So what are we actually looking for, though? Well, typically, when I give you a problem such as find the sine of pi/6, you would look at your unit circle, you'd find pi/6, which is right here, and then you'd say, okay, the sine is the y value, 1/2. The sine of pi/6 is 1/2. Or if I say, find the cosine of 3 pi/4, you would find your unit circle, you'd go, okay, 3 pi/4 is right here, and the cosine of 3 pi/4 is the x value, -pi/2 over 2. Or if I were to say find the tangent of 5 pi over 4, you would find 5 pi over 4 on your unit circle right here, and the tangent is 1. So now arcsine, arccosine, arctangent. This is the reverse. Instead of me saying what the radian measure is, and then you saying what the cosine, the sine, or the tangent of said radian measure is, we're going to do the reverse. I'm going to say, find the arcsine of -1/2. And now what you're going to do is on your unit circle, or more specifically, because this is arcsine, you're going to look at the right half of your unit circle. You're going to find where the sine is -1/2. Okay, so let's look at the y values here. And the sine is -1/2 at the radian measure 11 pi over 6. So what you're going to do is, instead of me telling you the radian measure, you find the sine of that radian measure. I'm going to give you, okay, what you would have found, and then you tell me the radian measure, keeping in mind that it's not actually 11 pi over 6 here, because I'm going to be looking from negative pi over 2 to positive pi over 2. So we have to adjust this and say not 11 pi over 6, this is negative pi over 6. Okay, what about the arcsine of the square root of 3 over 2? So on the right half of the circle again, you're going to look for where is the sine, the square root of 3 over 2. That's right here, actually. And so this has the radian measure pi over 3. So you're going to say the answer, the arcsine of the square root of 3 over 2, is pi over 3. Arccosine. Okay, for cosine, this one we're looking at the top half of the circle, not the right half. So the top half of the circle, where is the cosine? Negative square root of 2 over 2. So right here. The cosine is a negative square root of 2 over 2 at 3 pi over 4. Now, we don't have to adjust anything for the cosine. We only have to adjust for negatives in this quadrant for arcsine and arctangent. Okay, so that again is 3 pi over 4. And lastly, the arctangent of negative square root of 3. On the right half again, I'm going to find where the tangent is negative square root of 3. That's right here. Now that's 5 pi over 3, but I'm going to adjust. I see above that this is pi over 3, so then this is going to be negative pi over 3. Now there are going to be some other problems too where you're not going to be able to find that on the unit circle. So if I say find the exact values, that's going to say use the unit circle. If it says just find it or use your calculator, then we're going to use our calculator over here. Now we have to keep in mind that we've got to be in the correct mode. So unless it specifically says degrees, we're going to always assume that we're in radians. So I see that my calculator is in degrees right now. I need to change that. I'm going to hit mode. And then I see right here, radian, degree. I'm going to go down to radian, enter. And then you'll see two things. Now radian is flashing, and at the top, it says radian here. So now my calculator is in radians. I can go ahead and clear this menu and start putting in arcsine of pi over 9. So arcsine, that's going to be sine. So it says arcsine or sine inverse above. So I'm going to do second and then hit the sine button. And we'll see sine inverse, which is the same as arcsine. Since I'm in degrees, or since I'm in radians now, I can put in pi over 9. So pi over 9. And we see here 0.35657, etc. Let's just go to maybe 4 digits, 0.3566. 0.3566. Okay, the next one is arccosine. So second, this time I'm going to hit cosine to get cosine inverse or arccosine. And then now 5 pi over 7. Error domain. So why is that? Let's go to this. 5 pi over 7, that didn't work for arccosine. Well, what is 5 pi over 7? 5 pi over 7, if I look up here to my domain and range, I see that arccosine has to be between, the domain has to be between -1 and +1. So if I plug in just what is 5 pi over 7, oh, I see. Okay, so my domain is from -1 to +1. That's where x can exist. But this is 2.24 if I actually find what 5 pi over 7 is. That's far greater than 1. So this is outside my domain. I can't actually do the arccosine of this. So this is going to be undefined. Okay, so we get an error there. Well, let's continue. Arctangent. Second, tangent to get tan inverse or arctangent, and then negative pi over 4. This is negative 0.6658. Negative 0.6658. Okay, next one, arcsine of 0.42. So arcsine 0.42. Now, even though, oops, let's put in, there we go. Even though this doesn't have a pi in it, okay, we're still going to assume that this is in radians because it doesn't say degrees. So there's no degree marker here. Assume it's in radians. Let's go ahead and enter this. This is 0.4334. Okay, arccosine of 0.24. This is 1.328. So 1.328. And the last one, arctangent of 1.2. Is 0.8761. Okay, so we can actually find arcsine, arccosine, arctangent, or, sine inverse, cosine inverse, tangent inverse, using a unit circle. If it says exactly, okay, basically you're going to find that cosine, sine, or tangent on the unit circle. Right half if it's arcsine or arctangent, top half if it's arccosine. And once you've found that, you just say what radian measure is connected to that, correlated to that. And for your calculator, just go ahead and plug it into your calculator, keeping in mind that you've got some domains that have to, your input has to be within that. And if it gives you an error, it's likely outside of that domain. You can check it, and if it is, it's undefined. assume that you're in radians unless otherwise specified. So if it says degrees or there's a degree marker, then you can put in degrees.